Carl Sagan could not have predicted 2021, but he did see it coming. He wrote the following back in 1995, and we quote, "I have a foreboding of an America in my children's or grandchildren's time when the United States is a service and information economy, when nearly all the manufacturing industries have slipped away to other countries, when awesome technological powers are in the hands of a very few, and no one representing the public interest can even grasp the issues, when the people have lost the ability to set their own agendas or knowledgeably question those in authority, when, clutching our crystals and nervously consulting our horoscopes, our critical faculties in decline, unable to distinguish between what feels good and what's true, we slide almost without noticing back into superstition and darkness. The dumbing down of America is most evident in the slow decay of substantive content and the enormously influential media. The 30-second sound bites now down to 10 seconds or less. Lowest common denominator programming, credulous presentations on pseudoscience and superstition, but especially a kind of celebration of ignorance." Roll that around for a while. Those were among his final published words. He died 10 months later. Here we are 25 years later, realizing just what he was trying to tell us back.
Well, I can tell you, we shared it with America, but I can't share it with you. Okay? The most advanced offensive weapons on the planet, things that none of the superpowers have, developed by Israel, shared with America.
Ashton Forbes, you know, that super jacked guy.
Malaysian 370, contact Ho Chi Minh 120.9. Good night. Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
Even as these grainy satellite images released today by the Chinese government.
Why shoot it down, though, if it's not hostile?
Our technologies permit us to manipulate time and space.
Why the Americans would?
They leave distance annihilated.
This country is very powerful. Far more powerful than people understand. We have weaponry that nobody has any idea what it is, and it is the most powerful weapons in the world. Not even close.
I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that, one way or another.
Ashton Forbes live stream. Welcome, everybody. Thank you guys for being here. Wow. Okay, guys. Happy New Year right off the bat. We have some reflecting to do and some forward looking to do for the next year. So where did we start tonight? First of all, thank you for being here on this New Year's Eve, guys. A happy New Year's. 5, 4, 3, 2, 1. Yay! It's 2026 if you're listening to this maybe in the future. Okay, guys. We made 2025 0-point energy disclosure. The year of 0-point energy disclosure. And 2026 is going to be aneutronic fusion. You can call it disclosure. We haven't really exactly worked out the details. It's going to be aneutronic fusion. And I think it's amazing that there's probably hundreds of people listening to this, thousands or more, that are going to learn about fusion tonight. We made 0-point energy cool in 2025, and in 2026, we're going to make fusion cool. People are going to learn about fusion that never in a million years thought they were going to learn anything or know anything about fusion. People are actually going to understand about how electricity is produced. For the first time in possibly human history, people are actually going to understand what electricity means. I know, guys, we have high goals, big goals that we're trying to achieve. Okay, let me start with the search. Obviously, I'm the MH370 guy. I'm the guy that solved MH370. World hasn't really woken up to it yet on January 31st, 2025, but I have hopes. I have hopes for this race of primitives. I think that they might wake up to the technology that's possible in the next few years. They are searching again right now. And I guess maybe I should say this at the beginning of every live stream so that there's no possible way it can't get clipped. They aren't going to find anything. It's not hard, guys. Okay? Let me break it down for you. They aren't going to find anything because we have 2 videos. You just watched the whole intro to my live stream showing both videos repeatedly. 2 videos, and in the bottom left corner of one of those videos, there are Google Earth GPS coordinates. When I say that, I mean 6 decimal places. The coordinates move while the mouse cursor moves over the screen, indicating we're looking at software that was built with real GPS coordinates in it. So we know where that plane is in those videos. That plane is in the Nicobar Islands on the flight path of MH370. Do you get me now? No Inmarsat pings required. The plane disappeared out of the sky in the Nicobar Islands. That's like 2,000 miles away from the South Indian Ocean. It's not in the South Indian Ocean, bros. Unless they teleported it to the South Indian Ocean, it ain't down there. So next thing, because now half of you are like, Ashton, I believe you. You don't have to tell me that the plane's not in the South Indian Ocean. But what if they go and they teleport it down into the South Indian? What if they take it and they teleport it to the South Indian Ocean and then they find it and discredit the case? First of all, guys, if they go to that much effort, bravo. Let's just give it to them, okay? This is what I'm talking about. This is what I'm talking about too with my, Candace Owens culty followers. Like, guys, if they're that good, that they can get the DNA on the gun and on the bullets and get the father to turn in their own son, then just give it to them, man. If they can teleport the plane to the bottom of the ocean fully intact with all the bodies in it, with 10 years of decay in it, with 10 years of sediments on it for being at the bottom of the ocean, they can pull all that off. Or I'll give it to them. I'll admit they got me. They got me. Heck, if they can pull that off, even I'll start to wonder if there's another explanation for the videos. But the reason why none of that's going to happen is because it's too much work, man. It's too much work to go get a whole bunch of new people involved in a new cover-up for something that you covered up before. This is why they're not going to go to the effort of planting the plane in the South Indian Ocean so the guys can find it. They're just not going to find anything. And take it to the bank, clip it. The reason why I can predict the future is because I have psychic powers that the Xenu aliens gave to me. It's an amazing story that Joe Rogan, I'm sure, would want to hear. The Xenu aliens downloaded the psychic powers into my brains, and that's how I was able to figure it out. It wasn't science. It wasn't science or research or evidence or logic or critical thinking. It was just psychic powers is how I figured it out. Amazing story. Okay, guys. Let's get to the fun stuff. I'm tired of bullshit. I'm tired of politics, actually. It's holiday season. I'm on vacation, and I just want to do science. I just want science in my veins, injected directly into my veins, and I've got science for you tonight. First thing I want to do is I want to follow up on the Grok post where I was talking to Paul Sizz, talking to his ghost in the AI, in the machine, having AI psychosis. I asked him, what's the source? Remember that quote I said at the end of the live stream last night? Let me pull it up here. I asked Grok about, did Paul Sizz ever mention or reference Dr. Bussard, Robert Bussard? If you guys are not caught up, watch the last live stream. We go over another new science goat. I haven't ranked him on the scales yet. He's probably S tier. And he basically figured out how to combine inertial electrostatic fusion with magneto confinement fusion and get fusion to actually work. And he was just aiming straight for the best fusion, which is proton boron 11, aneutronic direct energy conversion. So holy shit. Whoa, there's the guy. That's the guy we've been looking for this whole time. And so the big reveal at the end of the live stream, the cliffhanger that I left everybody on, was I said that he had actually worked with Paul Siz, the guy that we talk about all the time, that we show his clips and videos, the guy that we were able to figure out that they used plasma sheath and turned it into a drone. He worked with him. They collaborated together. Not just collaborated together, but Grok said, here it is. Grok said the joint efforts extended to studies in the Air Force Research Lab, which, holy crap, alarm bells going off when you hear Air Force Research Lab. Integrating Bussard's IEC fusion designs into hypersonic vehicles. I mean, guys, this is like the ultimate year-end Yahtzee for 2025 right there. Because we've been wondering, okay, what are these orbs spinning around the plane? Everybody watching is wondering, what are these orbs? Yeah, we've been trying to figure it out too. It's not easy because we're literally trying to figure out customized technology that is not really believed to exist even today, that was already in existence and in space and in flight in 2014. What is this technology? And now we found it. Now we have found it. It is this. And why am I so sure? Because the guys that were collaborating together are all the engineers that I've been saying are the ones that are working on this physics on these black projects. All of the authors of the DIRDs. David Froning, George Miley, Paul Siz, Robert M.L. Baker, Franklin Mead, Hal Puthoff, Eric Davis, the whole crew. This is them, and he's just chilling with them. He's hanging out in the crew. He's in the club, no doubt. Okay, so I asked it, what is the source on that integrated Bussard's IEC fusion device? Primary source comes from a book called The Halcyon Years of Air and Space Flight by David Froning, a collaborator of both Siz and Bussard on advanced propulsion concepts. In the book, Froning describes years of collaboration with Bussard on fusion power and propulsion research for NASA. Wow. Including the use of Bussard's redesigned IEC system in NASP-like hypersonic vehicles. These vehicles featured high-speed, air-breathing ramjet, scramjet engines and rocket engines that heated hydrogen fuel via proton-boron 11 nuclear fusion. What? Froning also details specific Air Force Research Lab studies from Okay, so I have to explain. The Air Force Research Lab studies from 2002 to 2004, now we're talking about ball lightning study, teleportation physics study. That's when those papers were coming out, in the same time that these guys were writing these papers. Exact same time frame. And they were collaborating. Okay, just to give you guys, and here it is. The paper that I talk about all the time is the dense plasma focus paper, and this is the ultimate culmination. It turns out that the collaboration between these guys, Paul Siz, David Froning, George Miley, and Robert Bussard, was the dense plasma focus physics paper. The one that says they're going to use fusion to power gravity devices, quote unquote, gravity devices, that it can produce gigawatts of excess energy, that you in your home, you can have a floating Jarvis ball that probably just wirelessly charges everything around you. And it can be a little anime girl or boy or whatever you're into. Not judging. Okay. So I laid that out there. So the connection of Paul Siz, and just to show you the references that Grok brings back here as well, so that you can see. This is the one right here as well. Advanced technology and breakthrough physics for 2025 and 2050 military aerospace vehicles, that features Froning and Siz together. So, you know, how do I know this stuff's real? Well, I'm like telling you guys, this is the same thing where I'm telling you guys, like, the leaker of the videos is Edward C. Lin. Guys, again, the leaker of the MH370 videos is Edward C. Lin. I went through everybody. He's the only one that even fits any of the characteristics of being the leaker, and he fits all of them. He's the guy. Anyway, this is like that. This is like, hey, this is the technology you're seeing when you're seeing these orbs spinning around the airplane. You're not looking at little aliens, it's not little green men in little invisible crafts that are just got bubbles around them. No, you're looking at plasma fusion, specifically aneutronic plasma fusion. This is the rub. It's aneutronic because only aneutronic can be used for propulsion, because neutronic fusion destroys your craft. The thing about neutronic fusion is radiation destroys stuff. You need aneutronic fusion, and then you can also direct it and use that for propulsion. Got it? So this narrows it down a lot, what you're seeing in those videos. And the last clue before we get into the rest of this, they're spherical, the shape. When you're dealing with electromagnetism, magnetism specifically, the shape of the plasma is a big giveaway. The shape determines the configurations to how your approach to what your approach to fusion is. Does it look like a donut? No. It doesn't look like a smoke ring donut. Why don't those orbs look like a smoke ring donut? There's an answer for that. It's not a who knows. The answer is because of whoever designed that, it's basically going to be their design. And we found that the sphere, the cube inside of a sphere. It turns out it's not one donut. Your donuts are your superconducting magnets, and you configure your donuts in polyhedral configurations, and that creates a null zone. And you can use that to create your negative potential well. Your negative potential well will attract positive ions to it, and therefore the ions will come from every direction, and they're going to fuse right there at the middle. There you go. And yes, for my Czech Republic and, my Russian followers and Chinese followers and North Korean and Iranian, me love you long time. Me love you long time. Don't send the assassination squads for me. Look, I'm helping you out. Okay. One more thing before we get to this. Sal Pais has been blowing me up in my emails chat. I don't think he'll take that. I don't think he minds that I disclose that. And I got to point one of these out. You guys are going to enjoy this. Especially if you are a fan of Sal Pais, then I think you're going to enjoy this. How? Dude, Edge and Microsoft are the greediest mofos. Greediest in history. Like, nothing's easy with them. This is Sal Pais's the plasma compression fusion device enabling nuclear fusion ignition. So this is Salvatore Pais has 5 patents. One of them is a fusion reactor patent. And we noticed a while back that in the patent it mentions aneutronic fusion, which is our big topic of the year, 2026. And I want to point something out. Let me just go to the bottom here. I think I pointed out on the live stream that the idea of everything kind of collapsing towards the middle with this negative well potential was very similar to what Sal Pais was kind of explaining with his counter-rotating electromagnets or whatever that is. Well, I read this again, and specifically, Sal's pointing out you have to use a certain material so that these fusers won't melt. Because they're going to spin them really fast, basically, to achieve these super high magnetic field strengths. So Sal is definitely on the exact same physics line that we're on here when he's talking about this stuff in his papers. And obviously these papers predate me and this investigation. Now, just kidding. Sal's stealing all his work from me. I went back in time. Turns out in the future, I go back in time and I give Sal all this work, and then Sal writes these papers. That's how this all ends up making sense in the end, guys. Still doesn't make sense to me. I got a lot of questions for Sal, if we're being honest. Oh, sorry. I'm getting sidetracked. Take a look at the references down here at the bottom. Look at reference number 3. Reference number 3. R.W. Bussard, method and apparatus for controlling charged particles. What? There's not a lot of references. Whoa, my voice cracked, Chad. There's not a lot of references on here. Actually, like 3 or 4. A couple of them are Sal himself. Bussard is one of the references right on here. And actually, if you go up one higher than this is really interesting. Because knowing what I know now, this is crazy. The first time random person reads this, they're going to say, they're not going to understand. Why, guys, why is number 2 an interesting reference? That's Lockheed Martin's compact fusion reactor. Number 2 is Lockheed Martin's compact fusion reactor, guys. You guys not know that? I seriously wonder, do people even read scientific papers? I actually think that nobody reads them. I think that what's going on, like, how are we so retarded as a society? Is just like nobody reads them. Nobody can put the pieces together. Like Sal's second reference is compact fusion reactor by Lockheed Martin. That's Thomas McGuire. Third one is Robert Bussard talking about his inertial electrostatic and magneto reactor. Jay Park right here. This is the follow-up. This guy, I think, is the follow-up to Bussard, because Bussard passed away in 2007. So I think Jay Park is the crew that I think it is. Almost sure this is the people that took his work on. It's crazy that I know this now. Okay. Anyway. So I think I explained the rest of it, but basically the idea is that you're spinning these counter-rotating, and I mean, I think Sal's patents are 100% legit. Counter-rotating fusers, and the reason why this would make sense is, again, guys, the secret to this is relativity. The secret is if I shoot something this way and something else goes this way, from the perspective of this thing shooting over this way, it can look like that thing's moving faster than the speed of light. You can get these weird effects because our perception is based on how fast we're moving relative to other objects. So the secret, and this was also true of Paul Thibodeau's, his graphene microchip, is that the currents had to be flowing in opposite directions of one another. You had to have the circuit designed like this. It didn't work if it was like this. So Sal's saying if you do it like this, it's not going to work. But if you have one go like that, oh boy, my brain can't do this right now. But you know, you guys get the idea. Okay. Just wanted to highlight Sal's thing. I got more to talk about with Sal. I think we're going to talk to him this weekend, actually, guys. But I don't want to promise that yet. Should Google go nuclear? Thank you for being here with me, guys. Tonight we're going to watch this until we get copyright striked or whatever they do. We'll see if Google is an evil company or not. Background was, I bet you like nobody at Google had any idea who this guy was and how impressive he was. Shows up at Google 2006 and it starts talking about fusion, talking about his specific fusion reactor that he's been working on. We're going to skip through some of this. We're going to watch most of it because it's really, really good. So let's start a few minutes in where he talks about the type of fusion that he is.
Energy is released when the light nuclei are fused because the fusion intermediate product does become a fission product, but it fissions generally into other light atoms that are not radioactive. The ultimate fuels are fusing hydrogen nuclei together, and that's what runs the sun. Other common elements, light elements, can do that, and they include lithium, boron, and helium isotopes. Some of the reactions are radiation-free, and others are not. I just want to show you the energy levels. We all know about chemistry, fire. Hydrogen and oxygen burning makes H2O, and it gives you about 10 units of energy measured in electron volts. If you take deuterium and tritium, the two heaviest isotopes of hydrogen, and cause them to make a helium-4 and a neutron, you get 17.6 million units of energy. That's why fusion energy is so exciting. It gives us remarkable bombs and other exciting things. Fission on the left, there are 3 stages. If you have a heavy, unstable, nearly unstable nucleus and add a neutron to it, it will start that nucleus oscillating. The energy, binding energy of the neutron will cause the nucleus to oscillate, and eventually it will break into two parts and give more neutrons than it occurred at the beginning. And one of these neutrons goes around and can start the chain again. That's the fission chain reaction, giving you two radioactive isotopes. And that, of course, is what gives us Hiroshima and Nagasaki and all the excitement of the world. Fusion is a different thing. This is the deuterium-tritium reaction, giving you the helium-4 and the neutron. The others are similar. The one we're most interested in is this one, because it's very odd. It's a boron 11, which has a charge of 5 in the nucleus, and a proton, a hydrogen nucleus. If you add the two together, the binding energy makes an excited state carbon-12. Carbon-12 is one of the most stable nuclei in the universe, but when it's excited by the binding energy of the fusion process, it's unstable when it decays to a beryllium-8 and helium-4. The beryllium-8 very shortly, 10 to the minus 13 seconds later, decays into 2 more helium-4. So this process is unique. It's the only nuclear energy releasing process in the whole world that releases fusion energy at 3 helium atoms and no neutrons, no radiation. It's radiation-free.
Okay. Holy shito, chat. Oh, man. So put another Pulitzer up. Put another Pulitzer up on the... I don't know how many we're up to right now, but not just unlocking fusion. I don't even think cold fusion is really worthy of the Pulitzer. Proton boron 11 fusion, them having that figured out, turns out of all the chemicals that are out there, how many have we found? 180, 200, I don't know. A lot of chemicals on the periodic table. If you look at the fusion reaction possibilities, there's only one that has the configuration that you just saw on your screen, where the boron 11 converts to a carbon 12, but because of the energies that are happening, it's unstable. So it converts to I think it converts to a carbon 12 and then releases a helium. And then, the carbon 12 collapses down, that releases a helium to a beryllium, and the beryllium then collapses and leaves you anyway 3 heliums, or atoms, 3 helium atoms. So the other thing he said, the energy being released, the comparative energy being released when you do fusion is a huge amount. I think back to the cannonball, lighting the cannon example. You can use a small amount of energy to get a large amount of energy out. This is actually what Sal's paper mentions. We know this because I can light a fuse on a cannon, and a cannonball will go flying out, and all I did was light a fuse. So we know it's possible to have this amplification of energy. And that's what fusion is offering, but at the base level of reality. And it turns out proton boron 11 is the only fusion reaction by which not only do you get this huge cannonball out, that cannonball is, I think he said, like 1,000,000 times higher than conventional reactions. I think he mentioned the nuclear reactions. So anyway, the idea, though, is you're getting this huge amount of energy out. And proton boron 11 is aneutronic. Neutrons don't get released in this process, meaning there's no radiation coming out. It's essentially the perfect find when it comes to fusion. It's likely that unless we discover more things on the periodic table or some completely different understanding of physics, this might be as good as it gets. That's what they've been hiding. As good as it gets fusion figured out. Solved. And you can imagine, this is basically the normie equivalent. The normie brain equivalent of free energy. Somebody figured out perfect fusion, the best possible recipe, figured out how to get it to work. You don't need any other fusions once you have that. And they said, nah, that's a little too good. A little too good. We're going to have to cap that fusion to 0. Cap those solar panels to 22%. Okay, I'm not going to rant too much. Here we go.
Which means if you build a machine that runs on that and you turn it off, you can go sit on it. There can be no 3 Mile Islands and no Chernobyl. It's difficult to do, but these are the favorite isotopes to use, protons, deuterons, and tritons. And as I mentioned, this gives us this nearly 20 million units of energy. The intrinsic energy gain from DT, which is what the world is chasing, is about 2,000 to 1. But of course, the means that the world are following won't work that way. The neutron free.
Also, I just hella respect, dude. Old school overhead projector in 2006. This is like actually like people are gonna watch this in the future and be like, "Nah, I debunked that video." They're gonna be like, "People didn't use overhead projectors in 2006 like this." They're gonna be like, "Nah, it was all electronic back then." And even I'm gonna be like, "Yeah, I don't know. Is this video even real? Did AI make this video?"
Action here gives us 8.7 million.
Okay, nerds, focus on the screen. There it is, right? Proton boron 11 creates 3 helium-4. Lithium-6 plus lithium-6 creates 3 helium-4 as well. Wait, what? Why is lithium-6 mentioned all the time, but nobody ever like talks about it? Let's see if he mentions it.
Units of energy, and we can reburn the helium-3 deuterons when they fuse, split into 2 channels: a triton, which is radioactive, and a hydrogen nucleus, and a helium-3 and a neutron. That helium-3 can be cycled back to the exhaust system you have to have on the system and reburned with another deuteron to make more energy, so you get about 10.2 million units of energy. The D plus T gives you this ridiculous result where most of the energy is carried by a 14 MeV neutron. And the reason people look at D plus T, and I apologize for this graph, but this is a cross.
Okay, I'm going to skip ahead just a couple minutes. So basically, he's just showing cross sections. So we're too smart. We already know all about cross sections. It's like where the most probability of fusion occurring. Let me simplify it for you because I have psychic powers from planet Xenu. I told you I already know the answers, so I'm just going to tell it to you. Here you go. The Xenu space aliens told me. The secret to fusion is trying to get it down to a single point. Getting everything to a single point. Your magnetic donut is stupid. The star is not shaped like a donut. The star in nature, the ones we look at, are all spherical, and they're all spherical for a reason. It's very important. Get ready. Clip it. Get ready. The sun must be electric. There must be something focusing, pulling in from all angles, just like the negative potential well in Bussard's engine. And you can't just explain this with plasma flow because the plasma flow is unstable. We find all these instabilities in the plasma when we start researching it. We're like, oh, wait, no matter what shape we try to convert it into, it keeps wiggling out and getting unstable. Because there's something else to it. It's not just simple, oh, confine it, and then we should be good. No, the equations break down in reality because reality is a little bit more complicated than basic electromagnetic equations. Okay, I'm going to try not to crash out. But there's a lot of good stuff in here. We're going to skip ahead a couple minutes because this next part's really great.
Equilibrium. And they remembered the right-hand rule. You know, if you have a current flowing this way and a charged particle going this way, the force on the particle is at right angles to those two. The force in a magnetic field is not a restoring force. It doesn't restore the particle from the direction it's going. It's always at right angles, the right-hand rule. So they said...
So he tells him, oh, right-hand rule. Okay, so basically he's explaining why they did tokamak. So this is the story of the tokamak right here. They discovered the right-hand rule, and they were like, oh, okay, we could just make a donut then. So that it just constantly recirculates and there's no end to it. That's it. There you go. You just heard it.
You can't contain particles without a field because they'll run straight into the walls. So we'll put a magnetic field together and all the particles will gyrate on them. And this is going to trap them. So all manner of configurations were devised to trap them with magnetic coils that tried to bottle up the ends where the particles would all go out, and solenoidal magnets and cusp magnets and reflection and mirror magnets at the corners. Cusp, this is what Livermore spent $2 billion on. It's an impossible system because it has a point cusp, North Pole, South Pole, and South Pole is the equator, and the losses out these equatorial line cusps kill you.
Chat, oh chat. You're looking at field reverse configuration. The magnetic mirror setup, this was the precursors to FRC. The top right, I mean, I'll always notice it. The cusp. Okay, if you guys don't know what a cusp is, you're looking at it in the top right. If you're listening to this on audio, oh, wish I could help you. Imagine a Christmas present, like a bottle of wine, or like a cylindrical object, and how at the end it's twisted, that's the cusp in our magnetic mirror configuration. This causes the electrons to get trapped in the inside, and they keep bouncing back and forth because they're trapped by the cusp. And this creates a negative potential because all the electrons are trapped on the inside.
And so the physicist, of which I was one, said, let's close up the solenoid and make it close so the magnetic fields never end. And now the particles will stay here and circulate round and round.
Wait, one more thing. Sorry, there's just a lot. He's one of the physicists that figured out we should use donut shapes. Bussard is one of the physicists that figured out we should use donut shapes. Just got to throw that in there.
But there's a physics reason why you can't just do that. You have to have a poloidal current or circumferential current. So they invented the tokamak. Lavrentiev from the Soviet Union invented it. I often thought he invented it and gave it to us to make sure we never got there.
I often thought he invented it and gave it to us so that we never got there. Chat, my man is full of quotes. Get ready. That's just one. All the best quotes to just roast the hot fusion noobs, which, by the way, they are fucking noobs. We would 5-0 them, chat. Like, if this is a Counter-Strike or like a, Call of Duty lobby, oh my God, will we be roasting them?
And that's what we have now. And the tokamak, let me explain something. That's the ITER tokamak, 30 meters across, 110 feet tall. That's a normal PWR. This is about the size of the machines we hope to build. And the reason that these machines, these mixed magnetic confinement machines, which don't confine in local thermodynamic equilibrium, are so big is very simple. It's that picture I showed you of the magnetic field in a tube. All the particles gyrate, and they stay there very happily, so long as they never collide with each other. The moment two of them collide, the guiding center for that collision jumps 2 gyroradii. So every collision causes those particles to jump towards the wall. It's a random walk process, but it turns out it takes more than 1,000 collisions, scattering collisions in DT before you get a fusion reaction. That means you have 1,000 gyrocenter jumpings to go through before you have a probability of a fusion reaction. It's a random walk process, so the distance is the square root of 1,000 times the twice gyroradii. And that makes these machines have dimensions across the plasma regions that are measured in 2, 3, 4, 5 meters. You can't beat physics. The physics says it has to be that big. Furthermore, the DT reaction makes this 14 MeV neutron.
Okay. I think you just said something really important. This, again, like, man, you're only going to get this content on my channel and probably like a handful of other channels. Because you're getting like secret knowledge is what this feels like. And most people, it goes over their head. He's saying that when the fusion reaction happens in our plasma is our soup of positive and minus charges, our ions and our electrons. He's saying that there's this kind of not quite cascade effect, but this gyration that happens because the particles are hitting each other. And he says you have this scattering effect happen. So this one hits this one and that hits that one. And he says this takes a huge number of chains before one fusion reaction happens. So you can imagine your plasma soup is like the calm surface of the ocean, and it starts to get rocky, but it's got to get really rocky before the fusion starts to occur. So in the meantime, every one of those reactions is causing the plasma to expand. Causing the plasma to expand and start to shoot outward, aka hit your walls. And he's saying, oh, well, now your device has to be so big because otherwise the plasma is going to expand out. It's going to hit the wall. And then it's going to start to destroy and eat the wall. And then you're cooked. GG's.
The 14 MeV neutron is very, very energetic, and it has to be disposed of, and you have to find some way to create the tritium that you're burning because it's not a natural isotope. It's a 12-year half-life beta decay. And you create it by capturing the neutron in a blanket out here of molten lithium. The neutron is captured in the lithium-6, which then makes tritium. It's what we use for the bombs, and it's the lithium-6. And you have hundreds of tons of molten lithium sitting around this.
Did you hear him just casually throw in there? That's what we used for the bombs with the lithium-6. He just casually goes, that's what we used for the bombs. Mentioned lithium-6 right there.
Giant plasma container. And outside that, you have the superconducting magnets that you have to have the high fields. And this whole thing is an enormously expensive proposition, which even some of its proponents say they don't think it might ever be economic, but it's really good science. No. The problem that we saw was that everything that they're doing is highly radioactive. It's expensive. It's measured in tens of billions of dollars. The projected run-out cost of it is $12 billion. The program over the next 25 or 30 years is another $30 billion. The United States has already spent $18 billion chasing this tokamak dragon, and the initial electrostatic stuff comes in at the order of tens to hundreds of millions. There's no end in sight that we see in the tokamak world. Giant machines and no predictability. It's all empirical. One of my friends, Dr. Nicholas Kroll, a consultant to us, probably one of the top 3 theorists in the world, said some years ago he spent $15 billion studying tokamaks. And what we know about them is they're no damn good.
What the hell? Put this dude on the comedy tour. How is he not on the comedy tour, chat? We spent, 15 years, $15 billion studying tokamaks. And the only thing we learned is they're no damn good. It's even crazier that we're watching this in 2025, about to be 2026. And this video is 20 years old. And there's still, ITER's not even complete. They're not even talking about ITER being complete until like 2035. Like another 10 years for ITER to be complete. It's already been obsolete for like 20 plus years. And we're not even close to even being online. And it's not even going to add electricity to the grid. It's just a research facility. We are. Chat, humans are so fucking done. Oh, my God. Chat, if you're a young person out there, learn as much science as you can. Please, please, we need help. We need help out here. We're struggling. We're getting destroyed.
But fusion works. All you have to do is go outside in the daytime or go outside at night and look up. There are billions of fusion reactors. Every star is a fusion reactor. Every single one of them. And not one of them is toroidal.
Boom! He can't miss. It's hit after hit after hit after hit. Look in the sky. Every single star is a fusion reactor, and none of them are toroidal. Not one. Kaboom! That's the famous quote. It's from Robert Bussard, the guy that actually helped invent toroidal like magnets for fusion. He's one of the guys that helped invent it, and he's trying to tell people it's not the way to go. Nobody's listening.
And they're all held together by a funny force that's not a right-hand rule force. It's a central force field derivable from the central potential. It always points to the center, no matter what the particle motion is. It's always pulling it to the center. So the sun and stars run on fusion of hydrogen. 4 hydrogens together make a helium atom after you have some inverse beta decay going on. And the only other force we know that's like that is charge directed or mass directed, M1, M2 over R squared, or E1, E2 over R squared. There's the electric force, the electric field force on charged particles, the Coulomb force. Charged particles of opposite sign attract, and direct forces and charged particles of like sign repel. So what we have to do is find a way to take electric.
You knew it was going to come back to electricity.
Fields, next slide. That's all right. Electric fields, and make them accelerate the particles you want to collide toward each other. How can you do that? You can't do that with any assurance if you just take a plain parallel electrode and do it. But other people a long time ago said you can do it in a sphere. You can make a spherical electric field. You can make these particles come to a focus toward the center. With a 1 over R squared convergence, fusion power goes as the square of the density of the particles times the cross-section, times the velocity of the particles, times the volume over which that acts. N squared sigma V volume.
Ooh, boy, I'm feeling it. Do you feel the magic, chat? I'm getting watery-eyed. OMG. I'm going to play it again. Why are the orbs in a triangle formation around the plane, chat? 1 divided by R squared, chat. 1 divided. It's all physics at the end of the day. It's all physics at the end of the day. Hold up. Let's go back.
That's all right. Electric fields, and make them accelerate the particles you want to collide toward each other. How can you do that? You can't do that with any assurance if you just take a plain parallel electrode and do it. But other people a long time ago said you can do it in a sphere. You can make a spherical electric field. You can make these particles come to a focus toward the center. With a 1 over R squared convergence, fusion power goes as the square of the density of the particles times the cross-section, times the velocity of the particles, times the volume over which that acts. N squared sigma v volume. Density in these machines, because it converges.
So it's funny. Anybody can understand that. I love how he explains it, because you need somebody who just explains the math, who just says it straight to you. He's saying, how do you get fusion to happen? Well, the smaller the area that you're doing it in, the better. The faster the particles that are moving, the better. The more dense, the more particles there are, the better. Right? That's what you need. Take all these particles, squish them down into the smallest area you can, and get them to move as fast as possible. That's what we're trying to do. Well, what's a really good way to do that? Get everything to focus onto a specific point. This is the principles, actually, of the thermonuclear weapons that we were reading. Friedbort-Winterberg's polyhedral configuration. I can't stop thinking about it. I can't stop thinking about the letter to Ashton-Forbes, talking about the monostructures and configuring the monostructures together. I mean, that's polyhedral. That's what they're talking about. We have polyhedral configuration in this fusion reactor he's about to describe. We have polyhedral configuration when it comes to nuclear weapons, thermonuclear weapons. And we have polyhedral configuration when it comes to wormholes. Spinning polyhedral configuration when it comes to wormholes. I think these things, there's no chance they're not connected. The physics of all of them is most likely underlined in some truth about our reality. And if I were to really boil it down, if you want that hard, that spicy Ashton take, what is the most base element, most base particle or component to a particle we know? We have the quarks and the gluons, right? And I think there's always, they come in threes. They come in threes. I have a feeling that their coherence, resonance, whatever you want to call it, that forms basic particles probably also has a similar geometry to what we're seeing in the polyhedral configurations on the macroscopic scale. There you go. Okay. Spicy Ashton take.
Is 1 over r squared goes like 1 over r squared. Density squared goes like 1 over r to the fourth. This means if you can get a spherical convergence going, almost all the fusion will take place in a little bitty region in the center called the core. And we were not the first to understand that. In 1924, Irving Langmuir and Catherine Blodgett, working in the East Coast, wrote a paper on currents limited by space charge, differences in concentric flows and spheres. In 1959, Elmore, Tuck, and Watson at Los Alamos published a classic paper on inertial electrostatic confinement of the plasma. And what they talked about is putting a screen grid, a spherical grid, like two sieves back to back inside a sphere, and biasing that sieve to a positive potential so that electrons from out here would be attracted through the screen, would go inside, and would make it.
So it's crazy. I already know so much now that I know where this is going. Like, here's the problem right away. So you say, okay, you need to create a negative potential. You just need to create a negative, right? Because if you make a negative, the positive ions will go to it. If you're really simplifying it, you say, okay, well, just do the Thomas Townsend Brown effect. TT Brown, right, guys? Asymmetric capacitors, same idea. Asymmetric capacitors. Our asymmetric capacitor causes lift. This is the same idea as one side is negatively charged, so the positively charged side is lifting towards the negatively charged side. We're using that same concept, and now we're saying instead, make it happen in the middle. Okay, you would say, okay, well, build an asymmetric capacitor, but instead make it radial and make it towards the middle with the negative point. Here you go. Go build a thermonuclear weapon, North Korea. I'm teaching you the sauce right now. What's the problem? The problem is anything that you build, like look at what those Thomas Townsend Brown things are made of. They're made out of fucking aluminum. They're made out of aluminum. How hot do fusion reactions get? Fusion reactions get to 300 billion degrees or some crap. Literally any material you try to put in there is going to melt. It's going to melt. So you have to use the plasma itself. It's the only way. The only way to create the negative potential that you're trying to create on the inside is by having the plasma create the magnetic field that you need, the electromagnetic field that you need on the middle, which therefore now limits your options to using geometry. Get into geometry to cause it to do it itself. And therefore, what we're doing here. Here you go.
negative potential well because the electrons would slow down. Their kinetic energy would be transformed into potential energy of a potential well, and you could then drop ions into it at the edge. The ions would fall down and recirculate back and forth, like marbles in a well. And if they collided and didn't make a fusion, they didn't get lost like a tokamak. They would go right back up the well and give their energy back to the well. So you could make a fusion machine that way. The only trouble with this is they had a grid. And you have to have, in the case of electrons, about 100,000 transits of electrons before you will get a fusion out of the ion population you will put in. And no grid is that transparent. The best grids that Hertz and Farnsworth could ever build were about 95 or 90% transparent. And if you have a high interception rate on the grid, all the energy you put into the electron acceleration goes into the grid. And the energy is lost and the grid melts. It doesn't work. You can't get there with grids. Hertz and Farnsworth, Philo Farnsworth, who invented raster scan television, and Bob Hirsch, who was a postdoc, student, worked for Farnsworth, Fort Wayne, Indiana in 1967, wrote a classic paper here where they actually built a machine that inverted the Elmore-Tuck-Watson potential. They had a grid that was biased negatively, so they accelerated the ions directly, and that way they could get by the electron interception problem and replace it with the problem of ion interception, because the ions had to go through several thousand times and they could never get a recirc factor bigger than about 7 to 10. But this little machine that they built, which Hertz still has on his desk in Alexandria, Virginia, actually ran at 10 to the 10th fusions per second on DT, which was then and now still a world record for such a device. For that,
you can tell just listening to this, you can just tell how much work and research these guys have done, right? And like, you don't see that like this level of dedication to your craft and science anymore. You know, this is why the Neil deGrasse Tysons, could you imagine like Bill Nye the Science Guy, something like this? No way, not a million years. And this is where people should really have been taking whatever this guy tells me. I'm ready to believe. He could tell me literally anything, and I'd probably be really ready to believe it. But in this case, he comes armed with the facts, armed with math, evidence, science, reason.
Particular machine, but he did it with ion guns that were facing each other. So in a way, he had two guns that were spherically focused in a very carefully designed machine that Farnsworth designed. He was a brilliant designer and tested it. The total gain of the system was about 10 to the minus 6, meaning the power output versus the power in. And that was because of the grid loss problem and the other secondary problems of collisionality of the walls. There are two ways to do this. One we call ion acceleration and electron. Ion acceleration is what Hertz Farnsworth did, and there's the grid that kills them. And this is the Elmore-Tuck-Watson concept with the grids removed. What we did, the invention we made was very simple. It's elementary when you look at it. Just throw the grids away. Replace them with a magnetic field. Magnetic fields do not contain neutral plasmas worth a darn, and that's the tokamak problem. But they will contain electrons by themselves very easily because electrons don't weigh anything.
There it was. Boom. Boom. Throw the grid away, replace it with a magnetic field. The magnetic field will contain the electron because the electrons don't weigh anything. The ions are much heavier than the electrons, so they will not contain the ions, but it will contain the electrons. Boom. Boom. Hello. I wish national security would call me up. Then I'd have an excuse not to do this. I could be playing video games. I could be playing video games, chat. Real talk. I learned how to play Pokemon cards this weekend. My little nephew taught me. I could be playing Pokemon cards right now with my little nephew instead of explaining how you use magnetic fields to create a negative potential to make fusion happen, which I'm doing. So here you go. So we said we need to use the best of magneto-inertial confinement fusion and inertial electrostatic confinement fusion. When you think of electrostatic, just think of like static electricity, positive and minus charge. If we use a magnetic field, the electrons are too light. They will be trapped by the magnetic field. When they get trapped in the magnetic field, now you've got more negative electron potentials, negative potential here in this region. And I have a good idea of how we could do that. We create the cusps and we create a magnetic mirror.
A deuteron atom is 3,600 times heavier than an electron. So it's easy to contain electrons in magnetic fields, or there wouldn't be a variant associates up here building high power tubes. The point is, if you do that, you have no grid collisions. You replace that problem with the problem of how fast do electrons transport themselves across the magnetic fields to hit the walls of the magnets, which now become the magnetized grids. And you have a system which fundamentally you should keep open so that there can be recirculation. And what you do is you produce the Elmore-Tuck-Watson negative potential well, and then you drop ions into it at the edge. The ions see that well and they recirculate.
Did you hear the other thing he just said right there? He said, you want it to be open. You want to let the plasmas go flying out. Stop trying to confine the plasmas. He's like, it's okay to have this wiffle ball configuration too, so that the plasma can leak out. Because the plasma is going to leak out. It's going to be trapped by the magnetic fields. It's going to leak out, and it's going to form a bubble based on the magnetic fields. And it's going to come, and it's going to flow back into the middle again. And now you've created this system where it's just plasma flowing in, and the fusion is happening in the middle. And it's relatively stable, and it only requires a little bit of input to keep it going. Chat, ba-boom, chat, ba-boom. You're learning science on New Year's Eve.
I've showed here a central virtual anode because if you put a lot of ions in, it will push the anode up in the center as the ions collide. These devices are almost neutral. The departure from neutrality required to make a 100 kilovolt well is only 1 part in a million when you're at a density of 10 to the 12th per cubic centimeter. It's so small that we found that the current computer codes and computers available to us to analyze the problem are incapable of analyzing it because of numerical noise in the particle and cell calculations by a factor of about 1,000. The basic problem of this kind of fusion, this quasi-sphere, is to make a quasi-spherical field. We can't tolerate this mirror loss with the equator that Livermore spent the time and money on, or other people, not just Livermore. We have to have a magnetic field that has only point cusps. Think about that. If you put two coils together and you make a North Pole, and have an equator, you have this huge loss equator line cusp. There's no way around that unless the topology of the configuration is correct. There's only one configuration that works, and that's the one we patented. It's a configuration which is a polyhedron where the coils are all on the edges of the polyhedron, and the polyhedron has to have the property that there are an even number of faces around every vertex, so that alternate faces are north, south, north, south, north, south. If you look at the cube, which constitutes the normal Biconic cusp, it only has 3 faces around every vertex, and you have that line cusp problem. And that's the only thing we could find to solve. And that's the solution, was to make a system that's quasi-spherical. There's no magnetic monopole, so you have to do it from the surface. So it's a bunch of cusps sticking out like that. And there are no line cusps, so you have only point cusp losses. And we trap energetic electrons in that and form the negative potential well and drop the ions in, and they're focused at this 1 over r squared, and they oscillate across the core, as I mentioned. It acts like a spherical colliding beam machine, and the fuel gas input at the potential well edge is just nothing more than putting in neutral atoms and letting the incoming injected electrons ionize them at the edge.
Oh my God, I want to make some orbs, chat. Oh, what is he saying? He says it's acting like a particle accelerator. He's saying we're building this thing and it's acting like a little particle accelerator in the middle here, because you've created this negative potential well, and now you've got this plasma flowing all around it, but it keeps coming back towards the middle, and all the electrons keep being trapped. So you have a negative potential in the middle, and everything keeps coming back around. And this will create a spherical plasma. This configuration, a spherical plasma configuration. Yep, this is definitely, and he says it requires geometry. There's only one geometry we can make it to work, because you need to control, or you need to let the plasma leak out the areas that it wants to leak out. Why? Why, chat? Well, we are experts in fusion. Chat, I'm coming for, I don't know, who's the top fusion expert on the planet? Who is it? I don't know. Whoever it is going to be me. Going to be the top fusion expert. The reason is the plasma damages the equipment. It can damage the magnets. It can heat up the magnets. In a lot of cases, you need the superconducting magnets to be very cold. You do not want the plasma to touch anything. You don't want there to be walls. This is a big part of it. The plasma can't touch anything. So you need the geometry and the configuration to be very specific. The problem with the donut people, the donut plasma noobs, they are noobs, is that their plasma is going to touch the walls. It's unavoidable. It's unavoidable. The plasma is going to touch the walls. You should have never made your plasma like a donut. Do you see a lot of stars out there that are shaped like donuts? I don't. So there you go. We're just dropping truth bombs, teaching the secrets of fusion tonight. Hope everyone's having a happy new year.
Of the fuel, the neutrals gives you a low energy electron and a low energy ion. The ions fall into the well. The low energy electrons are heated by the incoming fast electrons very rapidly, microsecond timescales, and become part of the circulating system. Go ahead. I just showed this really quickly. Oops. There we go. This you've seen. The only thing I wanted to show you was this Maxwellian distribution problem. This is a local thermodynamic equilibrium, Maxwellian magnetic system. Here's the density distribution in the Maxwellian. Most of the energy is right here. You're sitting in a room where the temperature is, what is it, 78 or something, and all the particles are about 78. But way out here, 4 or 5 times out, are a lot of particles in the room that are much higher temperature than that. You don't feel them because they're not very many. And if you're in a system that has this potential, when we're describing, all the particles at the bottom are at one energy. If you have a 100 kilovolt well and you're dropping the 9 at the bottom, they're all 100 kilovolts. They're not spread about. And the problem is in that these mixed systems, the fusion reaction cross-section, which goes up with energy like that, only causes these little guys to make fusion. And all the rest of the particles are losses.
Wait. I think I just figured something else out. Oh, chat. Holy crap. We might move up like 25 ranks in the top fusion physicists tonight. This whole thing about equilibrium versus non-equilibrium, I'm finally getting my grasp on why it's significant. And I think he just explained it right there. Imagine your soup of plasma. The problem with the equilibrium situation is your particles are all of different energy levels. Yes, this one over here is a high energy, but this one over here is relatively low energy. So the problem here is that the number of particles in this distribution that are going to be ready for fusion is a tiny, tiny fraction. And then you need those to collide also. So the probability of all this happening is good luck, man. Good luck. This is like trying to say that like evolution happened without there being a divine creator. Ooh, we're getting religious. We're getting political here. Right? Where it's like, oh, they just accidentally, like a monkey humped, another monkey and then humans came out, right? So there had to be some other thing going on. We needed to throw another recipe, some other ingredient into the recipe of fusion.
And what that has too going for it is, in the case, I'm sorry to do more details like this, but this is cross-section versus energy. You may remember the PB11.
Oh, sorry, I missed the last part I was going to say. So the reason why the non-equilibrium part is so important is that you are now, what he explained here is that you are controlling the temperature. You're keeping all of these, I assume it's the ions, at a specific temperature so that they are ready for fusion, ready to go. And why this is creepy to me is that, okay, we are controlling the temperature so that we have a bunch of our soup is never going to get mixed into the final recipe. It's just there to help out. But we're going to have the soup that is ready to go that we're recirculating back towards the center core that we want to create fusion for us because we want to maximize the probability of our fusion. So we need all this stuff to be ready to go at the fusion temperature level. If I were to imagine what this is going to look like in a thermal camera, your non-equilibrium fusion, your plasma, there's going to be a huge, stable hotspot. Why? Because that's what a non-equilibrium plasma is made to do. The point of the non-equilibrium plasma is a bunch of the particles are the exact same temperature. They're in an excited state at a higher temperature, ready to go. And what do we see when we look at the orbs in the MH370 video? But we see this heat signature. Look at that heat signature in there. Look at how stable that heat signature is in that orb. I pulled up the video here, and you can see that there's clearly this blue, almost the same temperature as the background, but you can still see there's a field that's spherical. But you can see a green little orange slice in the plasma orb. And I would contend that that is your non-equilibrium plasma. Because the temperature's there, like how that part of the plasma is all uniform temperature, perfectly exactly the same. In an equilibrium plasma, you should not see any heat signatures like that. In an equilibrium plasma, it should all be the same temperature. In a non-equilibrium plasma, you can start to see shapes of temperature like that. Okay. There you go. It helps when you make actual videos you can show people of real plasma orbs that are fusion reactors that are teleporting planes away, because then you can understand the content a lot better. We're kind of at an advantage in that perspective.
160 kilovolts. Now if you drop a Z equal 5 boron into a 100 kilovolt well, at the bottom of the well, it has 500 kilovolts because it has a charge of 5 falling down the well. So I don't have to put 560 kilovolts into a system to make that one work.
Okay, we're going to skip ahead a little bit. Just a couple minutes.
The ion fusion power, just 2 points. People saw in what are called mirror machines. I showed you a picture with 5 or 8 to play with in ion flow control. The magnetic confinement of electrons is critical to ensure that we have what's called cusp scaling. I've told you about point cusps. Point cusps are the things that people saw in what are called mirror machines. I showed you a picture where the particles came in and mirrored and reflected. The reflection coefficient in a mirror machine, a low density machine like that, varies as 1 over the strength of the B field. That's not good enough. If you can somehow put so many electrons in there that you make the pressure balance equal between electron kinetic pressure and magnetic field pressure at the outside. B squared over 8 pi is the magnetic pressure, and NE is the kinetic pressure. If you can make those two things equal, you can't make the kinetic pressure greater because it will blow through the field. It's like blowing up a balloon too much.
He's talking about beta. He's talking about beta. I know too much. I'm too smart. The aliens they put too much psychic powers in my brains. Right? That's what he's talking about right here. He's talking about the pressure. Anytime I hear them talking about the pressure of the plasma pressure compared to the magnetic field strength, they're usually talking about beta. And he's saying you have to get it to 1. He's saying you need beta of 1, which again, this is why we invested in DJT, because there's only 3 companies doing this. Only 3. TA Fusion, DJT. Well, 2, I guess.
If you can make them equal, then you can push the magnetic field out. As you push the magnetic field out, the scaling ceases to be a mirror scaling and becomes what's called cusp confinement scaling. And it scales as 1 over the square of the magnetic field. And if we can do that, what it amounts to is we're making colossal holes through which the electrons go out, smaller and smaller and smaller, the harder we drive it with the electron injection, up to the point where we inject too many electrons and it begins to open up the cusp holes. And those equations are all understood now. And the question was, can we do that? We called it the wiffle ball effect because, as you know, the child's toy, the little plastic toy with the holes in it, if you put a marble inside it and shook it like that, sooner or later the marble inside would fall out a hole. It would find a hole. The smaller you make the holes, the longer it takes the marble to get out. That's exactly what we're trying to do. The other problem in electron confinement is magnetic insulation of the walls, all the structures that are out there, the containers for the coils, the things that hold the coils together, the metal parts. We have to keep them from being able to be seen directly by electrons without magnetic insulation. And that's turned out to be the devil in the details, which we finally resolved a year ago. So the key issues are these 2 things. Could we make wiffle ball scaling work?
He did just mention, I'll say quickly, he did mention basically that there was metamaterial requirements that were needed because the magnets have to be a very specific material. They have to be able to, remain superconducting at a certain temperature, critical temperature, etc.
And could we understand the mag-grid transporter? We have done both of those in the last 12 years. The approach is low-tech engineering compared to the monstrosities of these huge machines.
Yeah, we're going to skip ahead.
I once used to call them superconducting, general idea of the thing. And of course, being a good physicist, what you do today is you patent it. So we filed patents in 85 and issued in 89 and another one in 92, which we can pass over that one. And having filed a patent on it, because nobody seemed to have patented this configuration, which we saw was the only one that would work, to get rid of the grids. We said, let's see if we can't get a program to see if this is a good idea and will work. Well, the idea was to get a program that could produce practical nuclear fusion in a reasonable size, which would yield useful energy without radiation hazards. That seemed like a perfectly sensible goal that we should have pursued, but it didn't fit the model of the main programs simply because it's too cheap, too quick. I show this chart only because it's one of
chat. You've got a career this guy was DOE physicist. He was Oak Ridge, Los Alamos. He's the guy that helped invent toroidal fusion reactors, tokamaks, and he's hating on them. And he just says right there, they weren't interested because it was too cheap, too easy, too quick to build. Chat. Hopefully that doesn't get me banned. I'm not encouraging self-harm. I'm just saying, guys, someone just orb me to Diego Garcia. Chat, please. CIA, I get it. I get it. This is the punishment. This is my punishment. This is why they haven't done anything, because they know the more I dig into this, the more I'm going to drive myself crazy. Any normal person, any person didn't have extreme willpower would have already gone crazy long time back. Already gone crazy long time back. My man's just telling, I just say it again, please. It's too cheap and too easy and too fast. Sorry, DOE's not interested.
Configuration, which we saw was the only one that would work to get rid of the grids. We said, let's see if we can't get a program to see if this is a good idea and will work. Well, the idea was to get a program that could produce practical nuclear fusion in a reasonable size, which would yield useful energy without radiation hazards. It seemed like a perfectly sensible goal that we should have pursued, but it didn't fit the model of the main programs simply because it's too cheap, too quick. I show this chart only because it's one of the real practical engineering issues. There's physics in it, but it's really an engineering problem. Arc breakdown. In practical experiments, what kills us is arcing. Arcing occurs no matter what. This is a Paschen curve for plane parallel electrodes for hydrogen. The point of this curve is not that I choose any particular number on it. The breakdown voltage is that we have to be very careful in the pressure and the distance we have in the test setups. Remind the machine, it's the test setups that kill us. If the product of the two is too big, our breakdown occurs at hundreds of volts. We're trying to run these things at 10 and 20,000 kilovolts, or 10 and 20,000 volts. And of course, for plane parallel electrodes, it's one thing. If you have sharp points and corners and bolts and one thing and another, the breakdown occurs more easily. This is an engineering problem, not a physics problem. Oh, good.
Okay, so you have to control. This is the other thing, the voltage, right? The voltage. But these are all just, he says right here, he repeats this a lot. He says, this is an engineering problem, not a physics problem. The physics is solved. He says this multiple times. He says, we've got the physics figured out. This is how you make it happen. This is how you do fusion. This is how you mix together electric potential and magnetism to get fusion to work in a tiny little area. It's an engineering problem. These are just engineering problems that we had to solve. How do we get the material science to make it work? How do we get this thing that we're trying to get happen to occur with the right materials?
Now I want to show you some pictures of some of the devices we built. I might just say, we started, there's a slide first, I'm sorry. There's a view graph. Yeah. Can you go off that? Yeah. Here we are. That was the second thing. The first thing we built was a small open polyhedral coil that we ran at a few hundred volts just to show that the scaling would work. And we did that. We took the program not to the DOE, because I came from the DOE AEC, and I knew that was hopeless. No, it's not a pejorative comment. It's the program at the DOE, which we had created, was this monstrous money machine that still goes today. And people tend to protect their rice bowls, and that's how human nature is. And I knew that.
Bro, what? Come on, please, guys. Come on. He's just saying it, man. He's just saying it. You don't even have to listen to this guy, Ashton Forbes. I just keep telling you, I'm just a healthcare IT guy. Healthcare IT guy literally came out of nowhere on his holiday break here, reviewing literal famous physicists that died in 2007. And he's saying he literally helped build the fusion program. He didn't even go to the DOE to make this happen. He's the guy why we have tokamaks. And even he was smart enough to know, I'm not going to the DOE. It's too cheap. It's too easy. I knew they wouldn't be interested. Chad, I already hated government a lot. Just hates me. This makes me hate government even more. This is honestly just COVID all over again, but with fusion. It's like my worst nightmare. It's like, I'm not sure this is sometimes I actually wonder if this reality is even real or if it was made just to fucking torture me 24/7. It's like my worst nightmare, mixing the stupidity of COVID, the absolute stupidity of COVID, and the mass formation psychosis of everybody just believing the stupidest shit into physics, into electricity, energy generation, fusion. And everybody just going, yeah, no, it's totally normal that we just had no fusion breakthroughs for like 80 years. Fusion probably just doesn't work. Maybe the science books are just wrong on that one. Guys, you think the science books were just wrong on that one? Maybe fusion just doesn't work. We got the fusion bomb to work, but fusion energy, sorry, just that part's impossible. I hate people sometimes. I really do.
They would never want anything that would threaten those rice bowls. And in fact, I went to Bob Hirsch, who worked with Farnsworth, who was then research director at ARCO, and I asked him, Bobby, I said, what do you think we should do? He said, do not go to the AEC, do not go to DOE, because they'll never support it and they'll kill it. Take it to the DOD. So we did. We took it to the Strategic Defense Office, where Jim Ianson, who was an astrophysicist, was the technical director. He understood it immediately like that. He said, it's a great idea, we'll fund it. And funded it through the Defense Nuclear Agency. And then later on, it was funded through DARPA. This was an early DARPA program in 1989.
I think we're past. We're honestly past that. We're on full on Kill Bill. The timelines are all matching up. The timelines are matching up. So wait a minute. Now it's getting weird. So the guy that started building tokamaks didn't go to the DOE because he knew they're full of shit. He knew that they weren't trying to do it. He knew they were wasting their time on donuts, and they weren't trying to solve anything. So he goes to the DOD. He goes to DARPA, Black Ops, Black Programs. He goes to the DOD with this. We might have some weird shit going on here where, like, can you imagine that at the heart of all this free energy technology, fusion technology, teleportation technology, there could be like middle school level squabbles between like the DOE and the DOE, like the DOD and the DOE, like the Air Force versus the DOD versus the Navy, or like they're all like fighting for little scraps of like hyper advanced technology. Like, you can't have that. That's my fusion orbs. I feel like it might actually get to that level of stupidity. If it does, I hope that a comet hits this planet and just wipes us all out. Truthfully do. If that's what this comes down to, then the aliens win. The aliens shoot your black hole weapon, wipe us out. We just don't deserve this planet. I hope I'm wrong.
We built a machine that was 190 centimeters across. It had coils like that picture that I showed you. Wrong design in retrospect. It had all these big metal faces out here that were not magnetically insulated, and we didn't know enough not to do that. In fact, the paper we wrote on the experiments here and published in '94 erroneously tells you that the electrons got lost in the guns coming into the machine. They did not. They got lost after they got into the machine when they hit these metal walls that were not magnetically insulated. You can say, well, it's trivially obvious to even those of meanest intelligence to see that would happen, but it wasn't to us. And that was the DARPA program. After that, we tended to abandon that closed box configuration, and we set out and tried a little bitty machine, 5 centimeter radius, and this was made of solid state magnets, so it did not have the complete magnetic field. It had line cuts around here. You can see the electron burn where the particles that come out run into the machine. We did that just to test the idea of the polyhedral configuration. And the next slide, I guess. Yeah, that was the second one we built. This was called WB2. WB2 is 10 centimeters in radius, and look at it. It's a beautiful machine, but it's not sealed. These are all air core magnets, and they're uncooled because there's no way to cool anything at this size and scale. And so we had all the problem of outgassing from the insulation on the coils that crumbed up the vacuum system. And all the coils are touching. That's how you held it together. You welded them right there. Bad mistake in retrospect, but that's what we did. And we ran it. And the next picture showed you that's what happened when we ran it in 1994, September, October 94.
Holy effing shit. Am I looking at a fucking sun? Am I looking at a sun? Certainly seems like I'm looking at a sun. What is it, 1994 they did? Yeah, okay. They got some plasma orbs, chat. Anybody that says they don't have some plasma orbs, just send them this clip right here. This right there it is. They got some plasma orbs. There it is. I'm looking at a plasma orb. That's a plasma orb. Plasma orbs are real. No more debunking plasma orbs. Boom, bada bing, bada boom. By the way, this is like 35 years ago. 35 years ago, just FYI. Or wait, yeah, a long time ago.
We actually achieved a wiffle ball. This was the whole point. We achieved a beta equal 1 condition, but at very low energy because the drive systems were very low energy. When we cascaded in the middle, it brought the energy way down, but it was a wiffle ball. We ran all these tests on air because Maxwell doesn't care if it's a fusion or air, whatever it is, air or argon. And here you can see the high density in the core, and you can see the particles coming out through the cusp, and they turned around through other cusps. This was done in September 1994. the first test like this, and we thought, my God, what's happened? We've got an arc we don't want. A month later, in October 13th, we ran it again and finally realized we'd produced a wiffle ball machine. And that was a great and wonderful thing. It took us a month to understand what we were doing. And meanwhile,
Yeah, bro, the DOD was very interesting. Can you imagine how dumb anyone that thinks this is fake? How dumb would you have to be? Honestly, that he rolls up with this and he's like, "Hey, I made some miniature sun in my little magnet device. I mean, we welded it together. We shouldn't have welded it together, but there you go. Here's some images of the literal sun I created in the middle of it. Are you interested in this? I'm making miniature suns over here on Earth." Dude's the original Doc Ock. This was the writers of Spider-Man 2 probably were just like friends with him or like big fans or something, because there it is. That's the power of the sun in the palm of your hand. Damn, that's crazy. I just can't stop staring at it. That's just crazy. Look at that. Holy shit.
gave a talk at a meeting in Pittsburgh by the Navy, Westinghouse, and the American Nuclear Society on advanced technology for the 21st century on this program before we had really understood we had the wiffle ball. And the talk was apparently successful because the ANS wanted us to give it as a talk at their annual meeting in Washington in May. And I turned to our contract monitor and said, what should we do? Should we accept this invitation? He said, no. Now that you've got this thing working, no more talks. Don't go to any more physics conferences. Don't write any papers. Just lay quiet. Just do your work and don't publish. So for 11 years, we had an embargo on publishing. And that's why it's difficult to talk about it, because there's...
Oh, that's normal, chat. It's very normal. 11-year embargo on publishing scientific papers. That's how science works, right? Yeah, that's how science works. Can someone phone a friend? Is it Eric Weinstein? Hold up. Let me see if let's get someone call up Eric Weinstein, please, since he's the aficionado for all things physics, apparently, on social media. Hey, Eric. Hey, yeah, this is Ashton. Yeah, what's going on, brother? Yeah, how is science supposed to work where you put embargoes on everything so that people can't release scientific discoveries for 11 years? Is that how science works? It isn't. It is not. Oh, okay. Well, thank you. That's all I need to know. Appreciate you, brother. Yes, Eric says that's not how science is supposed to work, it turns out. Real call from Eric Weinstein. Yeah, there you go. Science is not supposed to work that way. Chat. I don't know if I'm going to make it. I'm trying so hard not to crash out. I really am. I'm just in the mood to lose my effing mind right now. We're listening. This guy puts all the pieces together. He's connected to the Black Project engineers that we've been studying. And he's out here just laying out the facts. And he doesn't care because he literally dies 1 year later than this. He's an old man. He's like, you know what? Y'all are screwed. He's like, I'm just going to flip the table over. He's like, I'm checking out anyway. He's like, guys, he's like, I got only a couple of years left. Y'all got to deal with this. He's like, everybody's dead that knew about this. So good luck. Here you go. Flip the table over. Peace out, Google.
So much stuff. We have hundreds of technical documents. The next slide. That was WB3, which was the larger version of WB2, and it was built only by budget limitations. We didn't really have any way to do anything bigger. We were running out of money. And everything else is ground, including the emitters. The emitters came in from the side over there. And what happened was we trapped electrons, and you can see they beautifully came out the corners, just like that WB2 picture. And 95% of the current went straight to the coils, to the walls, and to the cage. 95% saw the walls and the cage as an attractor for electrons. It went back to their original birth. It would not work. We can't do it that way. Next slide. We've tried also ECR. We wanted to ionize neutrals, find a way to control neutral ionization. Because if you can't keep the neutral population down, it will flood the core and make the will go away. And so we tried what's called electron cyclotron resonance oscillation. You put microwaves at 2.45 gigahertz into this thing, and every time, if there's an 860 or something like that Gauss line surface, at that line, that resonates EB over MC, it resonates with the microwaves, and you can ionize the neutrals very quickly in that situation. And we did this. This was ionizing inside the machine. The next slide shows us testing out and ionizing it outside. We proved that we could indeed ionize using magnetron radiation from a microwave oven, a $99 Sony oven. We took the tube and the power supplies out, and
hold up, chat. Hold up, chat. Did he just say? I think he said we can get our reactions going with a microwave oven. Do I understand that? Look, I'm not Neil deGrasse Tyson. I'm not the best physicist in the world. The debunkers were right. but my small mind thinks that I just heard that you can pre-ionize the plasma, get the plasma going with just a microwave oven, microwaves. I think that's what I just heard right there.
Four-way rectified the power supplies and drove it that way, and that was fine. The problem with it is that in later tests we found that, well, I'll show you the machine, which I did, we'll talk about it. Next one. Oh, that was the lady who's the president of the company. She's smiling because we wouldn't have a company if she hadn't been there. She took care of all the administrative garbage, if you'll pardon me for saying that. The leases, and not like that first one, which had those big plates. And see,
so these are the different iterations of his devices that they made, okay?
Very hastily in July and August of 2005, and we ran it in August and September and early.
I bet the ratios here matter as well.
October to get beta equal 1 beta, and then we ran it in November. Could I have the next slide?
Did you hear what you just said right there? I'm skipping through some of this. Let me just go back a few seconds here.
Doctors from coil to coil through those, so there was a local magnetic field around the spacer. And this we built very hastily in July and August of 2005, and we ran it in August and September and early October to get beta equal 1 beta, and then we ran it in November. Could I have the next slide?
Beta equals 1 beta. So again, guys, you only have to remember, if you're a normie, you only have to remember a few things. Neutronic fusion means clean fusion reactions. Beta equals 1, very important to remember. When you go look at the noobs with their metal donuts and they're trying to do fusion and you just laugh at them. Noobs. Their betas are like 0.1. Oof, feels bad. Inadequate, unable to satisfy you. Ladies, you know what I'm talking about. They say size doesn't matter, but when it comes to beta, size is everything, chat. 0.1 just will not satisfy the ladies. You need a beta of 1, 100%, 10 times greater. A lot more girth, if you know what I mean.
That's the coil system. Go ahead, next one. And that's how it looked finally when it went in the tank. And then go ahead. And that was it in the tank. It was really a very lovely machine. I think that's is that the last?
Chat, can someone do some homework as well, by the way, please? Very serious. Can somebody dig into this and see if we could steal this or what the deal is from a legal perspective? Like, I feel like inventions are only last for 18 years for patents. So if they patented all this, theoretically, we should be able to steal it now. I mean, I think those patents expire. I don't, there's probably something they can do, but anyway, someone dig into that. That feels like a good angle where we can figure out, because if he's being honest here, and this is the only way that works, then we're going to have to steal it. We don't got a lot of options. And I mean, I don't mean steal it illegally. I mean, take legal action to make it ours. Okay, that's how the government justifies when they bomb people. That's how we're going to justify legal action to take technology that should have always been ours anyway, for being real.
Oh, no, I'll go skip from that was WB6. WB6 worked. It worked like a champ. It did everything we had imagined that we should have done in the beginning, and it proved that we had all missed the obvious. For 15 years, none of our consultants, none of our review panels, none of our opponents, none of us, none of me, none of my staff saw these obvious facts. And we finally saw them in 2005 and built that machine. And when we ran it at 12 kilovolt drive and 10 kilovolt will depth, it produced a pulse of DD fusion to 10 kilovolts, which is very low energy. That was about 1 times 10 to the 9th fusions per second. That's 100,000 times or more higher than Hersh and Farnsworth ever achieved in any experiment they ever did. It's a world record. It was only a short.
There you go. How crazy is that? World record these guys did. So he's like, we were able to get fusion to happen at like, what was it, 100,000 or million times more than Farnsworth was ever able to produce. So essentially what he's saying there is that we unlocked it. We figured it out. So he kind of showed you the 6 different apparatus. If you guys want to watch the whole video, check them out. You want to learn about the individuals. It's basically them learning. Like, and this is why people say, Ashton, why don't you build something? Dude, it took these guys 11 years with a scientific embargo on their papers with funding from the government to do all of this. They had to make 6 different iterations of their fusion reactor because you learn something. You're like, oh, we messed up here. We could have made it better here. And you get, that's what science and engineering is. I don't want to do all that. I'm an influencer, chat. I'm a very important influencer. I just do things on social media. Very important job.
Time was about 1/4 of a millisecond. Doesn't sound like much on my watch, but it's several thousand electron transit times in the system. So from the point of view of the electrons, it's steady state. They don't know any better. They live on a different time scale. They're moving at 10 to the 9th centimeters per second. So next one.
Wait, right there too. I'm so glad I accidentally played those 2 parts because I wanted to mention that. He just gave a head nod to relativity. He said, you have to keep in mind, the electrons are moving at 10 to the 9th. You have to think of the time scales of the electron and how this is all working. And this is a head nod to our counter-rotating fusers or our counter-rotating current. Because of relativity, you have to think about how the electrons are moving and how time is flowing for the electrons themselves.
And in the process of this program, I've skipped over this, but we built a very simple thing, several very simple things called MPG, magnetic polyhedral grid. We wanted to try to see if we couldn't get somewhere with the scaling business by using water-cooled copper tubing and a single-turn coil. We could only run this at 2,000 amps because of the cooling limits, so we'd turn the water into steam. We couldn't drive it any harder. But the trouble is, with only a single turn, the ampere turns in the coils were so small, we could only get about 70 to 100 gauss out of these things. So the B fields were really small. But nevertheless, we were able to run this with a 30 kilovolt drive and a 27,000 volt deep well, and it made fusions, but the fusions were limited by the fact that we didn't have enough current and couldn't hold enough density with those low fields. We could only get a ball in the center about 4 to 5 centimeters going.
So what he's explaining right here is they started to use electromagnets. You don't need to use a permanent magnet. So he's saying, let's just see if we want to scale this up. Let's scale it down using electromagnets. And let's see if we used electromagnets, if we could get this to occur. And he said, yes, it works. You can do it that way as well. So you could use permanent magnets. You could use electromagnets. You just have to create your negative potential well in the middle. So the reason why we're doing this is because we're looking at the material science way for how do you build this so that it doesn't melt? How do you build this so that it's light enough so that it can fly around in the sky? It can't be super heavy magnets. You're going to pull that off, right?
And it was producing about 1 times 10 to the 5th fusions per second steady state. But it did prove the polyhedral principle again. The next one, and that's it in the tank. Go ahead.
Okay, I think we're going to skip ahead a little bit.
The odd thing we did was build it.
Here.
We managed to move the pressure, the starting pressure at which it died, up a factor of 1,000. We said, oh boy, we're winning. We're going to get there. Where do we need to go? We need to go to a pressure approximately 100 times higher to get to densities of ions high enough to make useful fusions in the middle when they coalesce. We were 100 times too low. We were not 10 to the 8th or 10 to the 5th times too low. So all we needed to do, we said, was put 100 times more current in it. Hot dog, we've got that capacitor bank. We can put 100 times more current in it for a short while. So we did. But we've done some electrostatic code calculations to show electrostatic potential lines, and the next one is even more compelling.
Watch this.
This shows us where the electrons went. And lo and behold, where do they go? They went to the corners, to the seams where there wasn't any magnetic field. Sure enough, the magnetic fields produced by the coils insulated the surfaces beautifully. That's where we got that factor of 1,000. But as the fields turned around and came out through the corner, they went straight into the walls. And that's a railroad track for the electrons to get lost. And so we put 100 times more current and we gained a factor of 2 in pressure. And we said, this is obvious. This is the obvious point that we all missed. It's trivial. Of course, you can't have anything that does that. You have to have a machine that doesn't do that. So that's what caused us to build, no, don't do that one, build WB6, where we didn't. Not the magnetic fields.
Look at this. What does that look like to you? If you don't say cymatics, you're wrong. Look at that. That looks like cymatics right there, right? And this is the confinement of the plasma within the boundary. When we say the boundary, we're talking about the walls. Now, the problem here, of course, is you can see that the plasma is arcing directly or is shooting out directly towards the corners. In a configuration like this, the plasma is going to hit the corners of your box, and it's going to destroy your reactor. So when you look at the plasma like this, you can realize, oh, what do I have to do to fix this? I have to change the geometry. I have to change the shape. I need to get rid of these corners on the edges here, or I need to let the plasma just escape out right there and have it come back and flow back around. Those are my options. But I can't have the plasma. Basically, I don't want the plasma at the dark spots on this map to ever touch any part of my device. Because if it does, it will damage the device, damage the reactor. Boom. There it is. Pretty cool, huh? I mean, the amount of stuff this guy comes armed with, Dr. Bussard, just incredible, man. Just straight up incredible. We're going to skip ahead a little bit here.
And he would like to pursue that program. Next slide.
I think he talks more about
one of the things on the outline said, I'll tell you all the things we've learned. I won't tell you all the things we've learned. It's too much. It's 11 years. But there's a paper that submitted and will be published from an international conference in Spain early in October, International Astronautical Congress, 1,500 people, 150 nations. And I put this paper into the Congress because I wanted to, for the first time in 11 years, put a summary out in print that says what we did and what we've learned and what it's about. So there is a paper available if anybody wants it that describes it all. It's not a very good physics paper because it doesn't contain all the equations, it doesn't contain all the theory and the models, but it talks about it all. And it gives a lot of references. And I think you can probably get that somewhere. I don't know where. But it's out. Point is, it's out in public for the first time in 11 years. Yeah. I guess no. Isn't there one about codes? Yeah, where? Oh, okay. Well, I can't help it. Let's see. We have codes. I'll just say we have codes that show power balances and these things. Palo Alto some years ago build a machine like that and put it in a blanket, put it in a container like that, and then Palo Alto some years ago looked at machines that would make utilities feel happy, and we think this is the best one, the DT catalyzed by the helium-3. We call it Cat A. It makes a neutron, you capture it in a blanket to make more steam. It minimizes radiation hazard. It has the advantage that it makes processed steam. This is not PB11 clean. This is DD making things that look like PWR neutrons, but it makes PWR steam. So you could build a machine like that and put it in a blanket.
What the hell? Do you just see what he just showed you? He just showed us the precursor to helium fusion. He said, we were thinking about reactors that we could build that would make the utility companies happy. What he says is he's saying that we were thinking of what kind of energy reactor we could build that it could be added to the grid, that they would be satisfied with. And he said the one that we came up with was helium-3, deuterium helium-3. That's the equations he's showing on the screen right here. Deuterium helium-3 fusion. There it is right there. Capture the neutrons in a boron 10 blanket. Helium-3 only in vacuum system. Minimizes material problems. Avoids enormous materials development time. Minimizes radiation hazards. Wow. Wow. What kind of world are we living in right now?
More steam, it minimizes radiation hazard. It has the advantage that it makes processed steam. This is not PB11 clean. This is DD making things that look like PWR neutrons, but it makes PWR steam. So you could build a machine like that and put it in a blanket, put it in a container like that, and then take that particular container and put it in the central part of a power plant where you have a number of them lined up in a row. And then that's the reactor building. The rest of this plant is normal plant, steam generators, steam turbines and generators and cooling towers. And this is a way you can retrofit existing fossil fuel fired plants. You come in, sit down next door, build a little.
This is pretty crazy. He's explaining how you could retrofit our old nuclear power plants right here. This is, again, 2006. He's like, guys, just build a fusion reactor next door, plug it into the steam reactor, and you can still use the steam cycle if you want. And now you can, boom, you've now turned your nuclear power plant into a fusion reactor. And now basically the same, it's already attached to the grid, so we don't have to worry about any of that. Damn, man.
Reactor building and tie it into the existing steam lines, and don't trouble the guys with the oil tanks, leave them there. But now you can turn the oil tanks off and run the thing on the steam that comes from the DD fusion system. And it's no different than a PWR system in the sense of the neutrons it produces, except when you turn it off, there isn't any radioisotope product to decay and kill you. We did most of our work for the Navy. Oops.
What? We did most of our work for the Navy. Sal Pais, are you out there? You watching, bro? So wait, this guy did most of his work for the Navy, making a fusion reactor, and now Sal Pais 10 years later is like, hey, I got a fusion reactor. I'm referencing Bussard a bunch in it. Okay. What's going on, man?
Somehow. And what we found for the Navy, we can make power systems like that. In the long run, the Navy's interested in PB11. The Navy wants to convert the whole fleet to electric ships. And
Wait. Slow down. Slow down, Unc. Wait. The Navy is interested in PB11 fusion. The Navy wants to convert to all electric ships. What? Sorry, am I in a different time? Did I change to a different timeline than this guy's in? I'm in the year 2025 in my timeline. We'll call it AF123 timeline. Is this video from a different timeline where all the ships are fusion electric powered and I just don't know about it? Is nobody just talking about this publicly or what? I'm confused here.
This is a way to make an electric ship that is nuclear but has no radiation, unlike the submarines. And it's relatively simple engineering. Commercial viability is like 6 to 10 years from the time we prove the first main demo plant. And the cost, as we estimated today, is 150 to 200 million. This was a chart from 1994. And the Navy system.
Sorry, this is a chart from 1994. This is a chart from the Navy was interested in proton boron 11 fusion propulsion in 1994 for their submarines, and it turned into everything electric. 30 years ago. Honestly, the easiest conspiracy to believe in is the secret space program conspiracy. Because I don't know how else. He said it's only going to take 6 to 10 years after 1994. So do I think we had plasma orbs teleporting planes in 2014? Yeah. According to this, if you just believe what they're saying and putting it on paper and on Google Talks, then yeah, I mean, he just showed it to you. You literally looked at it. Look, this is old school paper. This man doesn't even probably know how to use a computer. It's all overhead projectors for this man. There it is right there. Okay, let's keep going.
Which is, of course, why we died.
I mean, but who would want these things? Why would you want fusion anyway? All we're going to do is stop all greenhouse gases, end atmospheric smog, eliminate acid rain, decrease thermal pollution, stop nuclear waste forever, by the way, and end water shortages because we can use reverse osmosis, so we can remove the salt from the ocean and use it and turn it to drinking water for basically zero. With fusion power. Who would want all that? Nobody would want any of that stuff. So for unrelated reasons, it's just this has never come out to the public. Unrelated to these global problems that would all solve instantly. Okay. Oh, and here's more things. So he actually talks about here all the things that we could do to clean up the world with this fusion. You could actually, ethanol would potentially replace gasoline. Interesting. Fresh water from the sea, practical space flight, global economic stability. I'll let him speak.
Space flight practical if you had this thing. They're all improved. It brings global economic stability, and that's really the main driver. Cheap, clean power makes readily available, makes fixed energy prices. We don't have the OPEC up and down game. Low-value cane in third-world countries becomes a high-value export product, and all the third-world nations can become economically viable, provided you set up the business arrangements in the right way, so that the people who are building the plants and making the alcohol are forced to pay some portion of the profits back to the third-world countries from which they are taking the cane.
Yeah, Chad, I think I pretty much figured out why he died right after this speech. There it was. That was the moment right there. Shouldn't I put that slide in your presentation? The one that says, oh, if we release this, all the developing countries, all the third world shitholes, their sugar cane becomes worth like a ton, becomes worth like gold all of a sudden, because now we're going to all use ethanol because it's going to be way cheaper. So all of their product that currently they export for cheap now becomes like exporting coffee or whatever, becomes a cash cow. Yeah. The first world's never going to let that happen, bro. Not in a bajillion ever years. So I'd have deleted that slide. If I was editing, I'd been like, bro, life expectancy just went down like 5 years. You could have lived to 98, like all the rest of the Black Project engineers. But nope, you had to go talk about helping out the third world. Now you got to die at 80, like normal people, like a normie.
You can make a profitable industrialization possible in third world countries because they will have money. And that's the whole name of the game. Destroys the world market for gasoline, eliminates the oil cartel, and while it
destroys the market for gasoline and ends the world cartel. Yeah, that's what aneutronic fusion will do for us, chat. Do you have to wonder why we don't have it?
Oil states suffer income losses. What they really need is food. And how do you get food in many of those states? You need water to irrigate, to make agriculture. But these plants can make desalination plants so cheap that you can afford to make food. You can make desalination plants that run at 1/20th of the cost of what the Saudis now pay for desalinated. And leasing everybody in the world to build these things. We're going to build them. Lease everybody. GEC, UK, Korea, and Brown Bovary, lease them all over the world.
Here's the other problem, is that it's easy to build and it's modular, so it's small. So you can license, everybody could have one. You can have one in your house. Again, no bueno. The energy companies no like that idea. Gonna have to throw you off a building. Like, my man, this is where like he starts to go off the rails here. He was doing fine. He was talking to the Google people. Then you had to go start talking about cleaning up the environment and how we've basically been destroying the environment for no reason whatsoever. They don't like that. They don't like that kind of talk.
Lease them and charge them a royalty fee of 2% of gross. Always working at one end of the machine and build and test the demo plan. We can do that in something like 5 years.
He's like, and by the way, we only need like $150 million and we can build one of these plants. We can basically do what Helium Fusion, this is literally what Helium Fusion is doing. Helium Fusion is playing this out right now. TAE as well, presumably. Then this is their next proposal. You guys are going to see this on the news. And again, I only know this because I got a psychic brain download from the Zeta Reticuli aliens, right? Not because I did hard research. No. Hard work doesn't pay off, Chad. Never work hard. Never try at anything. Just wait for the aliens to brain psychic download it to your mind. You're going to find out the Helium Fusion is going to come out and be like, our reactor, our thing costs like $200 million to build our next power plant. And it's going to be like literally this exact proposal, right? You're looking at it. Now, it's going to be a different configuration, but you get the idea. Same idea. He just laid it out for you. He said, if we're going to do this commercially, one way to do it is doing helium-3 reactor. Okay. Now, we're going to get to the questions here. Right off the bat, first question. I think I promised this one already. By the way, yes, it's standing applause. Bravo. Just masterclass, bro. Masterclass presentation. They're unassailable. Came with the facts. Came with the facts.
I'm sorry I took so long. You have we should have questions and answers if I can give any. I guess, yes.
Community in these microstructured and nanostructured metamaterials have negative index of refraction for microwave. I wonder if those expand the design options for electrostatic confinement.
The question is, if the metastatic materials which have strange indices of refraction, will that give us any hope in the magnetic confinement business? I don't think so, and the reason has nothing to do with their properties. I think that they're just in another world that we don't interact with. Everything we are doing is in enormously high magnetic fields, and it's an environment that's totally hostile. It's very high energy particles that are, in the case of PB11, up to 200 kilovolts, and huge surface damage from impacts. And so I don't see how the solid state devices have any particular role to play in this machine. They might have some use in external control systems, but not in the device itself.
So really interesting. I mean, first of all, question gets asked right away. What about negative resisting metamaterials? So in 2006, asking that question is wild. That is a wild question for 2006. You asked that in 2020, no problem. Everybody knows about metamaterials and the UFO community and what have you. For him to come out and be like, hey, what about negative refractive index metamaterials? Could those be used? I mean, you're talking about using electric potential to create a voltage well. The problem, he says, is the answer is also very intelligent. It doesn't matter what your metamaterial is. We're literally melting shit. It's 300 billion degrees, bro. I don't care what your metamaterial is. Nothing's surviving 300 million degrees. So one avenue is, could it be used for a control system or other aspect of the device? Potentially. And I think there probably is room for improvement in terms of what the material is, in terms of the superconducting magnets and whatever. But the geometry is what's allowing for this null zone or this negative well potential in the middle. And that's being formed by the magnetic fields, because the magnetic fields don't melt. Boom. There we go.
And that may be a bad answer, but that's the only one I know. Here, it's called WB7 and WB8. Right here. The first year will be 2 small test machines, which are...
Somebody asked him, like, what's the next prototype? Why haven't you built a prototype? Because the last prototype, WB6, melted. And he says, though, there it is that the next thing would be build another prototype underneath this grant, or whatever it would be, and then you're going to build your reactor. This is exactly what Helium Fusion and TAE are doing. Those reactors that TAE and Helion are doing, they're doing this. They're building their prototypes so they can say, yes, this works. We can prove this works. Now buy one of my large, whole power plants that I'll build for you with the giant reactor and batteries and everything.
Called WB7 and 8 that are like WB6, but not, because they're not circular coils, which are not optimum. They will be actually coils that follow the polyhedral configuration, but they will be carefully spaced, and we expect them to work 3 to 5 times better than WB6. One of them will be a truncated cube, and one of them will be a truncated dodecahedron. And those are two machines that we will do just exactly what you asked. We will do WB6 improved 50 times more so that we can hammer that data down so that the senior review panel will have something to look at.
Here's the risk.
Yeah.
Cube and a dodecahedron. They're all polyhedral configurations. Doesn't this remind you guys of sacred geometry? When I was watching this, I couldn't stop thinking about the letter to Ashton Forbes and the sacred geometry and the monostructure thing. In fact, I even made a clip of it for you guys because I was like, it was blowing my mind the more I was sitting there thinking about it. Where is it? Here it is.
Products or application you are now working on is correctly based on superconductivity. The number of orbs you've been speculating about is correct. The fourth orb decides where the object ends up. The technology is based on structures, simple and beautiful structures that lets us use the unlimited power that is everywhere and step outside what I would like to describe as perceived reality.
Yeah, we're about to find out that the universe is fake and gay. Holographic principle is going to be the winner.
It'll be there. And I wouldn't convene that senior review panel without having that data to say, look, here it is.
Helium nuclei from the core?
There's no that I should talk about that. When you do PB11, you get 3 helium nuclei. One of them is at a fixed energy of 3.46 MeV, and the other 2 are average 2.4 something. And they're average because the beryllium-8 that decays is moving, so they run between about 100 kilovolts and a couple of MeV. That helium, you have to take the energy out by having grids external to the machine, electrically biased grids. So the helium nuclei charge up against the grids, and when they run out of energy, they will hit that next grid. Okay, when they hit the grid, they become neutral because they're neutralized by the electron. And then you have to have an exhaust pumping system that pumps. Really don't. I mean, engineering is not, you just don't do that. You have to have really good people. Westinghouse and GE and Raytheon and a lot of good people come in to help you and to do all the engineering of that heavy stuff. You want to do 200 kilovolt standoffs? I don't do that. EPRI funded Westinghouse to do that, but we have 800 kilovolt megavolt transmission lines.
One other thing he mentions is that I think people understand is it takes a huge amount of effort. A bunch of people, you can't just do all this in your garage. He's like, we had to have GE and Raytheon, these other companies come in to do the engineering. We've got the physics solved, but the engineering of this is like a huge endeavor to pull off. So this is the other aspect people have to understand. Even people at Google are wondering because they think that you're just going to do this in your garage or something.
Running across the country, so people do know how to talk about those things anyway. The impediment has always been money. We've told the Navy and the DoD since 1989 that the cost of this program in today's dollars is $200 million. We've had it in report after report after report. And they knew that. And they knew that from the beginning. And they said, we can't do that. Why can't you do that? Because if we do that, I'll tell you the story. If you do that, it becomes visible to the staffers on Capitol Hill. It's a big enough budget item that people see it. Once it becomes visible to the Capitol Hill staffers, everybody on Capitol Hill knows that this is what the Navy is doing. The DOE will see it. The DOE will say, no, you can't do that. We have the charter to do fusion. And that's the end of the program. Because
what? Zapper, by the way, thank you. We'll get your donut at the end, but he just said it again. He said, we can't fund $200 million for this. The government came back and said, we can't fund $200 million for this next phase because the DOE will get wind of it and they're going to come in and they'll shut it down because they'll come in and they'll argue that we are the ones that have the charter for fusion. Nobody else is allowed to do fusion. And the Navy will have to argue, well, yeah, we were using it for our propulsion, blah, blah, blah. And the DOE will win out because they're the ones at the end of the day that control fusion. Wouldn't the DOE want fusion to come out? Why would they be against this? Chat. Why would the DOE be against this coming out? Don't they want fusion for the world? They keep saying that they want fusion and energy for the world, unless, I don't want to be conspiracy theorist, but what if they've had it figured out? What if they greedily want to monopolize it for themselves, use it strategically, militarily, and not let anybody else know. What? Yes, there it is. The magic word of the day. National security. That's the secret word of the day, chat. National security.
They were co-opted and shut the Navy down. So the Navy had to fund us at a low level, below the radar screen of politics. And that's exactly what happened. And it's nature, it's life. And
he just says it. He's like, well, they had to fund us on a lower level because of politics. And that's what happened.
We are. The funding has always been way too small. We had a staff between 5 and 10 people doing this whole thing for 12 years.
Chat, is this why Salvatore Pais got shut down too? Like, is this a similar reason why Sal got shut down? Like, anybody that they just know that if you get too close to fusion, they're just going to shut you down.
Wave ovens. I mean, we actually learned all the physics slowly, but we learned it all. And the engineering problems, of course, are way beyond those budgets. We couldn't even run the machine steady state. We had to go to these cap banks. Going to small size and cap banks makes the experiments very difficult because you don't have time. You can't build cooling. You can't control the gas flow. We had sub-millisecond pulse gas inputs, but we couldn't turn them off in time. It's very hard. It's much easier to build a big machine in the sense of the control problems. And we need, not we, I don't need it, but whoever does this needs a lot of help. The Chinese at Hefei could probably do it very straightforwardly.
Like, this is the best part of the whole thing, where my man, this is like your drunk uncle at the Christmas party. I'm the drunk uncle sometimes. The drunk uncle all of a sudden just starts going like, hey guys, okay, we're at the end. You know what? I'm just gonna riff. I don't got a lot of time left. You know what? It was Tesla. It was Tesla science all along. We had the physics figured out. You know, they didn't want it. Turns out it's a bunch of politics up at the end. Like, holy crap. Okay, Unc. Okay, Unc, hold up, Unc. Let me get my second martini. I want to enjoy this. Let me get some mixed nuts. It's holiday time.
You said that a lot of people are brain in some of these areas are over 70 years old. That seems like a problem going forward.
The guy just asked him, he's like, hey, you guys are all like 70 years old. Seems kind of like a problem going forward.
Yeah. The question is that I made a sort of jocular remark that the review panel would probably be people over 70 years old. I don't know that that's true. I'd actually have some people in their 30s on it because I know some very bright guys. The problem is that engineering schools in nuclear engineering and in physics-related physics really don't train people in this field anymore, and they haven't for 20 or 25 years because it's an arcane field that doesn't fit modern technology. We've all gone to silicon. We've all gone to microchips, and we've all gone to solid-state devices. And there are very few people who make giant 4-foot high power tubes. It's not like the days of Langmuir.
It's an arcane technology, quote unquote. Arcane. He's talking about, and he's saying everyone went on to microchips. But what about fusion? We left fusion behind. We left plasma physics behind.
And Tesla and those guys, this is really back in that world. And
he literally just referenced Tesla. He said, this is literally back in that world of Tesla. You got a guy that worked on for the DOE, Oak Ridge, who made a working fusion reactor, who's sitting here saying this is like Tesla stuff. It's arcane technology and referencing Tesla. Chat, I might need a therapist to avoid the crash outs. I might need a therapist. Kids are growing up and they think Tesla's a fucking mythical figure, chat. They think he's just, like Colonel Sanders, right? They think he's like the Colonel.
It's not that anybody's evil, it's just that there wasn't any market for people like that. So the people who lived through it, I'll give you one example of one of the people I'd like on that review committee. His name is Bob Simons. He was head of research at Varian for years, and then he was head of electron devices here in San Carlos. And he's been following this field and working in it for 35 years. He's 86 years old, but he's smart as a tack. I mean, he comes from another world, and there's nobody trained in the schools that you can turn to. I happen to know some good people at Sandia and Los Alamos, some really bright guys who I would turn to put on this panel because they think outside the conventional magnetic confinement box, and that's the problem. The box has become so big and so well funded, it supports thousands of people in hundreds of labs all over the world. Everybody for decades has been thinking about Maxwellian equilibrium plasmas, and it's very hard to break that mindset. If you live in that box and your income comes from doing research in that box, how do you ever break out of it? Well, I know a few people who do. I know a man at Column who I would bring in as the director of research from England because he's appalled at what he's doing. But
King. Just keep cooking, King. Keep cooking. Nobody let this man stop talking. He's like, hey, these people are stuck in a mindset. They're stuck in a Maxwellian equilibrium plasma mindset. They're not thinking non-Maxwellian distributions of their plasmas. They're not even thinking about all this. They're not even being trained to think about all of this. This is a man who understands that the ether exists. I've learned enough. I've listened to enough. I'm a good enough judge of character. I've listened to enough Black Project engineers. This is a man that knows that the ether exists. Guaranteed, chat. Guaranteed.
He's working on JET, which has been being studied there for 24 years now. It's a very difficult problem, but it's a real problem. And I even discussed this with Bob Hirsch, who's still in Alexandria, as to where we would find people. And how do we find people who are credible? Well, I can find a lot of people over 65 who are really credible, who have been brilliant engineers in their lifetimes, and who have national and international stature, who I would trust. And I don't own these guys. They're just friends of mine. And we don't lie to each other. And they would tell me what they really think. And that's what I want. I want the brightest guys I know to be there to tell me what they really think. Should we go ahead, or should we say, no, it's too big a risk and why bother? I don't think that's going to be their answer.
Talk your shit, King. Talk your shit. So he's essentially saying here that we are losing this technology. Like, he's trying to explain how we lost the technology to go back to the moon, how we lost the technology to make the fog bank material. We're kind of retarded, but we're actually kind of good at keeping secrets. Turns out we're kind of good at keeping secrets to the degree where we keep the secrets from ourselves even. We keep the secrets from ourselves. And that's the reason why all these scientists are like over 70. And there was no transition plan. Nobody back in the 50s was like, hey, we found the secret magical technologies. We better have a succession plan. Nope, no succession plan. Edward Teller dies. We got nothing. It's just gone. And we brainwashed ourselves intentionally to hide it. Brainwashed ourselves from ever even looking at the science, looking at the physics. We brainwashed ourselves from solving fusion. That's pretty crazy, man. There's a lot of very intelligent people that are stuck and can't think outside the box of equilibrium plasma and tokamaks. They think that's got to be the answer because they were told to think that. The same way where people are wearing masks today because they were told to wear masks like 5 years ago and they still won't take them off. There is a direct analogy there. Okay, we're going to skip ahead to the closing speech. Oh, a couple other things he says here. I took some notes. He says there's a rich history of code simulations. And what you're noticing is to do these calculations takes huge databases, huge supercomputers to pull this stuff off. So there's a direct connection between all this research and advancing computer simulation, advancing computers to be able to do the simulations, to be able to model these interactions and reactions accurately as they're evolving in real time.
Yeah.
Okay, so let's go to the end. He does a little speech here at the end. It's only a couple minutes, I think. This will be our moment of Zen.
Time, and you have a lot of money, and if there's any serious interest in changing the world on a long time scale, it's not going to return anything in 2 years. This may be a place that should pay some attention to this. Obviously, we need an angel. There are a lot of people in this country who have multi-billion dollars who could fund this at lunchtime. I have no intention of spending my life running around talking to them all. I'm too tired. If somebody wants to do it, they'll figure it out. And if they don't, it'll be in print. It'll be everywhere around the world, and I'll give it away. We have the patents on it. Somebody will pick it up somewhere. China's a participant in ITER.
Pretty crazy. Doesn't it feel like he's talking to us in the future here? He's like, I have the patents on it. He's like, somebody will pick it up. Even if this doesn't happen, he's like, somebody will pick this up eventually. It's out there. I've solved it. I've made it public. Ooh, creepy. And then he starts talking about China and ITER here. ITER.
%. So they don't want to be thought to be not members of the community. But China is at Hefei building some very interesting tokamaks of the kind that we were looking at 20 years ago, quite apart from ITER, that will beat ITER to the punch. And I think that we have a lot of people elsewhere in the world who don't have the same kind of mental constraints that we have in this country. And for all I know, that's what will happen. I would prefer we would do it in the United States with people like you who have vision and go power and are excited about things. And so would Jim Benson. We would like to see Space Dev and Benson Space Company take this thing over and maybe work jointly with whoever else partners with it and go for the space engines. As I told Noah, when I was 7 years old, my objective in life was to fly to Mars. It still is. And these machines can do it because they'll make space engines 1,000 times better than anything else. Single stage to Mars in 4 weeks. HTOL to Leo at $25 a kilogram. 76 days to Titan, one of the moons of Saturn. It's a very remarkable engine.
So this is where all that math where people are talking about we can get to Mars in 1 month. This is where that comes from with plasma engine. This is who they're referencing. Talking about his stuff. Pretty crazy. The people that we have been seeing in the lore about like, how would we get to Mars? Oh, here's this crazy idea. It's like the guy we're actually talking about here. Wild.
I wish I had a plan. I could tell you what a plan would be, going to all the foundations and all the multi-billionaires, the people who SpaceX and all those guys, Elon Musk and Jim Bezos and those people, but it's too tiring.
Elon!
And I'm tired in that sense. I'm talking to people. And the problem is the fusion community is so old and so entrenched, you always run against them. And the immediate question you always get when you talk to people who are not personally themselves, understand the curiosities of the physics and why it really will work, even though you can tell them it will. Either they believe you because they know you, and they know you don't lie to them, or they say, well, it sounds good, but I have to have it vetted by somebody, and they don't know where to go to vet it. And the first question you always get is, how come if it's so good, the United States government isn't doing it? That's the first question. I've had that question in France and other nations. That's not unreasonable. The answer is very long and tedious, and it sounds like sour grapes, but it really isn't. It's just reality. In a private world, in the world of private industry, where people don't think like government, they can understand that. You do what you do because it's right, and it will work. You try it. That's what you do here, I think.
Wow. Wow. Get me some more popcorn. We're going to leave it on that. Wow. He says, well, if it's so good, why doesn't the government do it? If it's so good, why aren't the government just doing it? If they've figured it out, if they solved, this is exactly how the Elon Musks, the rich billionaires think. They go, oh, well, if it was so good, I mean, the private world, it would become popularized. People would commercialize it. They would make a lot of money. They would become trillionaires. Elon Musk literally believes this because he says that on Joe Rogan. He said they would be competing with me if they had it, unless it's sequestered, it's hidden under national security, in which case you get nothing. And so it's this bureaucratic political mess is the reason. It's a long, complicated story, just like he says, for why we don't have it. Let's do some super chats, guys. Thank you very much in the Pilled chat. You guys have been going off today in the Pilled chat. Thank you very much, John Glock and the rest of the crew in the Pilled chat. Slug Trail, I'll see you, brother. Appreciate you guys. Thank you guys in the Rumble chat as well for hanging out with me tonight. I'm going to start with Zapparoo. Huge super chat. Happy New Year. He says, fantastic year. I salute you. Thank you for all the time you've spent presenting research and interviews. This is truly scientific pointillism. And the picture you're creating will finally expose the technology. Happy New Year to you, Lulu, and the entire Four Orbs chat. Thank you, Zapparoo. You're the bomb, brother. Appreciate you. Denver Royal says, why no love for Ark of Rodin? Yeah, Rodin, Jamie Burdoff. I think a lot of people understand that it has to do with this certain geometry. And everybody starts taking it in their own different ways. Guys, I talk about the mental aspect of this. I'm not even joking when I say that this kind of stuff drives people insane. I have watched it drive people insane. And I can see when I first got into this, I thought, why are all these people so woo-woo? Because this stuff drives you woo-woo. You start wondering, what's the next layer? What's the next thing? And that's the reason why I try to avoid it, try to keep as grounded and just, this. We're talking about teleportation and plasma orbs zapping stuff away. I'm trying to avoid going to that high level of how everything is connected. We're all one being, whatever, you can get kind of weird and hippie with it. That's not really how I roll. But what I'll say is a lot of people have discovered this and they've all gone in their own direction. If you want to go full woo-woo on it, and this is the reason for everything in the universe, go nuts. For me, my objective, whatever it takes to get that technology. So I got my own little Jarvis ball here. I want my own little Jarvis. My Ani. My Ani boo. Please teach wormhole physics to the noobs. Right? That's my only goal, chat. That's my goal for 2026. One little Ani Jarvis ball. Okay. Carrie, Ethernet subscriber, like Iron Man, building a suit in a cave. Bussard built a sun with a microwave. We spelt sun wrong, but we'll let it pass. It may have been intentional. Possible double meaning? Leave it at that. Thank you very much, Carrie, Ethernet subscriber. Appreciate you. Quantum Queso Dip. Love the content. Looking for more knowledge. 2026, A Neutronic Fusion, chat. A Neutronic Fusion. We're looking at DJT. We're looking at Helion Energy and any other A Neutronic Fusion companies that pop up in 2026. And then Mick Leonard said, best planet on the channel. Appreciate you guys. And one last, Jaleel Robinson. Thank you very much for that $5 super chat. Another great live stream. Guys, I hope you have a really great new year. I hope you guys enjoyed ZPE Disclosure 2025. Coming back next year with a brand new content. Not really. Same content, same place, more knowledge, more physics in your head. Love you guys. Peace out, MH370X. Later.
In the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate. Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum squeezed so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course. Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. Thin shell formalism placed so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Forces balancing the plate, creating the throat, open the gates, from Earth to the stars in a single bound, a shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread. Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow. From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night. With wormholes and stargates, our path is clear.